Hello, this is Robert Davies with the Utah Climate Center. So we've established that Earth's climate is currently changing. In the next few episodes of Utah Climate Notes, we'll overview why climates change. And the key notion in this conversation is going to be energy flow. To begin, it's going to be helpful to distinguish between different kinds of change. For example, we know that climates change seasonally every year, and that this seasonal change itself is very different from place to place. We also know that there are regional scale cycles, such as the Dust Bowl of the 1930s, that last upwards of a decade, or maybe even two. And we know that there are whole planetary shifts in climate, such as ice ages that last tens of thousands of years. In short, changes in climate occur on different timescales, from seasonal to several years to centuries and even millennia, and on different size scales, from local to regional to global. Now, these different scales of time and distance encompass the different flavors of climate change. And underlying each of these different flavors of change, from regional to global, from short-term cycles to long-term shifts, are different physical reasons or mechanisms. Understanding the basics of these different climate change mechanisms, then, is key to understanding the climate change underway today. The key concept in this section will be energy, and more specifically, energy flow. More specifically still, two kinds of flow: the flow of energy within the Earth system and the flow of energy into and out of the Earth system as a whole. Now, there are many details, of course, but the basics are these. Energy flow within the system moves energy from equator to poles and from oceans to atmosphere. Another way to think about this is as a redistribution of energy. Now, climate changes that occur from this redistribution are short-term and they're regional. In other words, energy redistribution gives rise to regional climate cycles. A warm winter in Utah, a cold winter in New England, a few wet years in Brazil, a few dry years in California. In addition, energy redistribution also causes the year-to-year ups and downs in global temperatures. Energy flow within the Earth system, then, is the mechanism responsible for the short-term variability in the climate system. Energy flow into and out of the Earth system, on the other hand, is different. Think of this kind of flow as energy balance. And it's not too hard to see that when this flow is out of balance, when the outflow does not equal the inflow, it's the entire global climate that changes. Climate changes that occur from an energy imbalance tend to be much longer term. From a human perspective, they're more permanent, and they tend to be global. An energy imbalance, then, is the mechanism that produces a shift, a trend rather than a cycle, in the entire global climate system. So, energy redistribution underlies short-term changes that are regional and temporary, climate cycles, while energy balance underlies long-term trends that are global and permanent, climate shifts. The trick, of course, is that all of this is happening at once, and teasing out the changes that are cycles versus trends is one important task of climate science. So with these basics in place, our next few videos will examine these different flavors of climate change in a bit more detail. Utah Climate Notes is a collaboration between the Utah Climate Center and Cooperative Extension, making essential climate science real for the people of Utah.